Welcome back to the Deep Dive. So today we are looking at a stack of papers and tech demos from Google DeepMind. And frankly, they make the current wave of AI video generators look a bit, well, static.
It really puts things into perspective, doesn't it? I mean, everyone is talking about tools like Sora. You type a prompt, you get a video.
Right.
But we're looking at Project Genie today. And the headline here isn't that it generates video, it's that it generates gameplay.
Right. This is the shift from just passive consumption to actual interaction. We're not watching a movie. We're grabbing a controller virtually. Anyway.
Exactly. This is what they're calling foundation world models. So Genie doesn't just predict the next pixel to make a pretty picture.
Oh.
It predicts physics. It has to understand cause and effect.
So let's unpack the mechanics here.
Yeah.
Because the jump from, say, Genie 1 to the new Genie 3 is just, it's massive.
It is.
We went from these basic 2D platformers to, what, 720p real-time playable worlds. But the breakthrough seems to be this latent action model, the LAM.
The LAM is the absolute core of this. It's the brain. And it solves a huge, huge problem in computer science. The unlabeled video problem.
Okay, this is the part I really wanted to drill down on. DeepMind trained this thing on hundreds of thousands of hours of internet gameplay videos.
Yeah, just YouTube videos, things like that.
But a YouTube video doesn't come with a log file of what buttons the player was pressing.
Right. The AI sees a character jump, but it doesn't see the A button being pressed. It just sees pixels moving up.
So the latent action model is essentially reverse engineering the controller.
That's the perfect way to put it. The LAM analyzes the visual change between two frames, and it infers the discrete action that must have caused it.
Wow.
So it learns that, pixels moving up rapidly equals some specific latent action. Let's just call it action 7. It doesn't know it's a jump button, but it knows that triggering action 7 causes that kind of vertical movement.
That is just wild. It builds a controller from scratch just by watching. And to make this all run frame by frame, they're using this Spatio-Temporal tokenizer.
Which is a very fancy way of saying compression.
Uh-huh.
Video is incredibly heavy. So to make this work in real time, the tokenizer crunches all that video data down into these compact tokens, similar to how ChatGPT turns words into tokens.
Okay, so it can predict the next frame almost instantly.
That's the idea.
So we have an AI that can basically dream up a fully functional, physics-compliant video game. But looking at the DeepMind strategy docs, they aren't trying to compete with Xbox here.
No, not at all. The gaming part is almost a byproduct. The real customer isn't a gamer.
It's a robot.
It's a robot. Embodied AI.
Right.
Precisely. If you want to train a robot, say a robot dog, to navigate a construction site, you have two options. One, you put the robot on a real site.
Where it falls over, breaks something.
Or hurts someone. It's expensive and slow. Or two, you use Genie. DeepMind has this system called the SIMA interaction loop. They take an agent, the robot's brain, and they just drop it inside a Genie-generated world.
So it's like an infinite flight simulator, but for everything.
It's an infinite curriculum. The robot can practice crossing a bridge or opening a door in millions of slightly different hallucinated worlds. It learns the logic of it all without ever, touching grass.
And the sources say this data actually transfers over to the real world.
It does. They're seeing real success transferring these dreamt skills to hardware like the Univail robot and Agibot's Geo1. The AI learns the concept of a bridge in the simulation.
And that helps it recognize a real bridge.
Exactly.
Okay, but let's do a reality check, because the tech specs show some pretty serious bottlenecks. This isn't something we're all going to be running on our phones tomorrow.
Not even close, no. It is incredibly computationally expensive. To run Genie 3, you basically need a dedicated TPU or a very high-end GPU. Per user.
And the memory window is really short.
Very short. Right now, sessions kind of tap out at around 60 seconds. And because it's a probabilistic model, it's guessing what comes next. It suffers from hallucinations.
So the walls start melting.
Or objects just change shape. Or the world forgets where you were 10 seconds ago. It doesn't have object permanence over long periods.
There was one quirk in the testing notes that I just loved, though. The Nintendo knockoff problem.
Oh, yeah. That was a real headache for the developers, apparently.
It sounds like it. So it trained on so much internet footage that early testers found they could accidentally regenerate. Super Mario 64.
And it didn't just look like Mario, it felt like Mario.
Right.
It replicated the specific gravity and the jump physics of the game just from watching videos of it. Google actually had to go in and implement these strict IP filters to stop it from generating Nintendo or Disney content.
Which, that really proves the underlying point, right?
Yeah.
It understands the physics.
It understands the rules of the world it saw.
Yeah.
We're really shifting from AI that just chats with us to AI that simulates reality to learn from it.
It's a massive step.
It is. And it sort of leaves you with this lingering thought, you know? If AI can now dream up physics-compliant worlds to practice in, as these models get better and better, at what point does the simulation become indistinguishable from the reality it's trying to learn?
That is definitely something to chew on. Thanks for listening to The Deep Dive. We'll catch you on the next one.